Hello everyone. So, today we're going to be learning about what's called hypotenuse leg congruence. This only works for right triangles, and it's pretty straightforward. So, basically, what this says is if you have two right triangles and they both have the same length hypotenuse, and just as a reminder, the hypotenuse is the longest side. Hypotenuse. So BC and EF would fit the bill on this picture. And the hypotenuse is always the opposite side to the right angle in a triangle. So that's like the opposite to the right angle. What I mean like that. So if those two sides were the same in two different right triangles, and going with our little diagram, that would imply that BC is congruent with EF. Alright, so if the hypotenuses are the same and a pair of legs have the same length. Now the legs can be any of the other sides besides the hypotenuse. So it could be BA, it could be AC. It doesn't matter which one. But if you know that between the two triangles that they have the same leg measure, so in our picture here, it would be that AB is congruent to DE. That alone is enough to prove that the two triangles themselves are congruent. So by showing that the hypotenuses are the same length and a pair of legs are the same length, you can then demonstrate, okay, triangle A, B, C must be congruent to triangle DEF. It's probably the simplest congruence theorem to work with. So let's see how it goes. And just keep in mind it only works for right triangles. So if it's not a right triangle, there is no way it's hypotenuse leg. Alright. So here we have a nice problem. Triangles LMP and MNP are right triangles. That's one of our givens. And as we can see, we have the right angle in the diagram. We want to prove that LMP, the triangle, is congruent to NMP, the other triangle. So, we list our given, which is that they're right triangles. Okay. And our other given is that ML is congruent to MN. That is statement number 2. So that's also a given. Okay, so ML is this length right here, and MN is this length right here. Now what you should notice is that in the two triangles we have, that's the longest side. It's the side opposite to the right angle. So that's our hypotenuses. We know that the two hypotenuses are congruent to each other. So hypotenuse, hypotenuse. Sorry, the tablet's a little sketchy. Hypotenuse. Yeah. Ugh, that looks terrible, but whatever. Okay, from there, our third statement is that MP is congruent to MP. And whenever you have the same thing congruent to itself, that's your reflexive property. So, reflexive property. Okay. So, that is the side I just marked, which happens to be basically the leg of these two right triangles. If it helps you figure this out, like visually, imagine if we like separated the two triangles, something like this. We basically, alright, it was given that the hypotenuses were the same. Here's the right angle. What we basically did with the reflexive property is show that these two legs were the same. If we basically split the triangles apart. So, if the hypotenuses are the same, a pair of legs are the same, hey, that's our hypotenuse leg postulate or theorem, whatever. So, HL congruence. As you can see, it's not that bad. So, let's look at one more. Okay. So now we have to fill out both columns, but, always start with what you know, which is your givens. So our first part of the given is that triangle WVX and triangle YZX are right triangles. Okay. Triangle WVX, and I'm just gonna abbreviate it a bit. Triangle YZX are right triangles. It's terrible. Alright, and the reasons given. So what that's going to mean is that, alright, it's a little weird, but basically the angles that look like right angles are going to be our right angles. So I'm going to mark them right there and right there. Okay. Our other given is that WV is congruent to YZ. Again, that's a given, which I will mark. WV is right here, and YZ is over here. So that would be our legs of these triangles, the legs of the triangle, because they are not the sides opposite to the right angle. And then we have the third part of our given. X is the midpoint of the side WY. That's a given. Alright, so out of the three givens, the first two are pretty straightforward, but the third one is kind of the key to solving this. If you look at WY, you'll see point X is in the middle, and whenever you have midpoint in your problem, you're going to use the definition of midpoint. So if X is the midpoint of WY, then we must have that WX is congruent to XY. So WX is congruent to XY. Why? Because definition of midpoint. Definition of midpoint. And that's all we need, because these ones are the hypotenuse, because they're across from the right angle. We have from the given that the two legs, one of the two pairs of legs in each are the same. So that's enough to justify that triangle WVX is congruent to triangle YZX. And because of our hypotenuse leg congruence theorem, postulate, whatever you want to call it. So as you can see, it's relatively straightforward. Only works when you have a right triangle. So that's just something to be aware of. And since you're dealing with sides, the hypotenuse is a side, the legs are sides. Remember, if you look at that list of reasons we started with, you only have like 3 reasons sides can be congruent. Reflexive property, it's either given or it's definition midpoint, which is the one we used here. So you'll find that any of the hypotenuse leg problems are relatively straightforward. All right, so I'll see you in the next video.